we are going to begin our exploration into vectors and representing vector quantities along with this. So let's start with the concept of vectors. You guys have not, as far as I know mathematically, have seen vectors before. So a vector is a quantity written with usually a symbol, a letter, numbers, with a little arrow above it. That's not a full arrowhead, it's kind of a partial arrowhead. And this shows that we're denoting both direction and magnitude. And what is magnitude? Well, magnitude is that modulus that we saw before, except now instead of going from the origin, we're going from an initial point and a terminal, and we're ending at a terminal point. So in the polar form, when we were looking at that modulus, that R value for polar form, we call that a modulus. Here, it's a magnitude, and a magnitude is the length of the vector. So from initial point to terminal point. Our vectors also have direction to them. Again, in this case, this one is kind of like a 45-degree angle, so it's a direction to the right. Upper right. And so this is how we can see what a vector is. And again, it's written with a little half arrow above it. And a vector here can be used to determine position of one point in space relative to another. So how we're going to use the vectors in this example is we are going to see an airplane. So a plane is flying due north, but is pushed off course by a crosswind blowing east. At 1 p.m. the point is at 10:10, and at 2 p.m. the point is at 104:10. So let's draw this out. Okay, I'm trying to get this as straight as I possibly can at a 90-degree. There we go. So this is the course that the plane was supposed to take. He was supposed to start here at 10:10. And in an hour, possibly might get a little bit further because of the crosswinds, but really should end up somewhere up here. But because of these crosswinds, the plane is blown off course. So the plane is blown off course by 100 miles. Because this, or sorry, 90 miles, because this is 100, this is 410. All right, what we first want to answer here is we want to find the speed of the wind and the speed of the plane due to the engine. Basically, there's no wind pushing, it's just the engine alone taking the plane over. So looking at the wind is an eastward wind. And so we're looking at the wind moving east in that direction. Okay, so I'm going to find the change of my wind. In other words, the green is my wind, so it's going to be the change in my x values. And we are looking at 100 minus 10. So I got distracted because I noticed I didn't put another parentheses there. And so what my change here is 90 miles. Now 90 miles does not give our speed. We want speed over our distance over time. And looking at our word problem, we have 1 p.m. and 2 p.m. So that's an hour's time. So the wind was basically traveling 90 miles per hour, or 90 mph. Well, what about the plane engine? The plane engine is going to be my y. So the change in engine is equal to the change of y's. And in this case, it's 410 minus 10, or 400 miles. Now this does not tell me the speed of the engine. So the speed of the engine is going to equal the 400 miles divided by 1 hour, or 400 miles per hour. So in this case, we're going to look at composite form and a way to rewrite this. So composite form, let me introduce that, C-O-M-P-O-R, component form. I don't know why I said composite form of a vector. So the way I write this is represented by the coordinates of this kind of arrow guy. This kind of represents those arrowheads that we're talking about with direction. What they describe is the vertical and horizontal changes of position from the initial point to the terminal point. And in this case, the vector includes both eastward and northward, I'm having such a hard time saying that, northward changes. So now what we're going to look at is the vector here. So I'm going to label this vector A, B, and C. So if I'm looking at the vector A to C, I'd write it with a little half arrow, and this represents a horizontal change of 90 miles and a vertical change of 400, because again, horizontal change of 90, vertical change of 400. And so the way I would write this is I'd write this as 90, 400. And if I want to write this in matrix form, this would be 90 over 400. So the change in the plane's location is 90 and 400. Right, let's look at another part of this problem. How can you describe the direction of the plane is heading? How fast is the plane moving with respect to the ground? Okay, so I'm going to choose orange. So first let's do the direction of the plane. Well, I know here that this is 400. I also know that this is 90. I'm going to find the angle right here to find the direction, theta. And I'm looking at opposite over adjacent, so I'm going to use that arctangent or the inverse tangent of opposite over adjacent. And what we are seeing here, so this is angle, plane is moving. And what we get here is, if I'm thinking of this, this is both positives for in quadrant 1, so we don't have to worry about it being like 127 degrees or anything like that. I could use my calculator for this. Make sure that your calculator is in degrees and not radians. We get 12.7 degrees roughly. All right, so now I want to calculate the magnitude. From A to C. And again, it's going to basically be that distance formula. We saw the modulus using the distance formula. The magnitude also is going to use that distance formula because we're looking at the distance from A to C. So in this case, it's going to be 90. Because we already found the distance. We found x1 minus x2, or x2 minus x1. We found that here with the change of the wind. Plus the change of y, y2 minus y1. That's what this actually represents, y2 minus y1. And this equals x2 minus x1. So the change of x's plus the change of y squared is going to be 400 squared. And what we found here is that this is going to equal 410 miles. And we could actually say that the plane, this is going in 410 miles per hour, because again, the plane travels for 1 hour. So the plane travels about 12.7 equals 12.7. And the speed of the plane of this direction, so speed of plane is equal to 410 miles per hour. All right, so there's our plane. There's our plane where he's at right now. He is totally off course. If you were really flying this plane, you would have to adjust to try to get here. And there's a lot more than just looking. There's something called a VOR that will tell you that you're off course and help you get on course by basically using a compass or a unit circle to give you that direction on course. So it does use all these vectors to figure out where you are. All right, guys, so this is the end of this video. If you have any questions, always feel free to ask, and I will catch you in the next video.